Alright, in this lesson we're going to look at what the inverse trig ratios are. Now the word inverse means upside down, back to front, inside out. You're doing the opposite of inverse. You're doing a reverse process. When we look at the three trig ratios that we had, that we looked at in the opening lesson, we see that the sine of an angle is equal to the ratio of the opposite side divided by the hypotenuse, and that the cos of an angle is equal to the adjacent side divided by the hypotenuse, and that the tan of an angle is equal to the opposite side divided by the adjacent. And these ratios will always be constant for any given angle. They'll always be constant. And we had this little mnemonic here called SOHCAHTOA that would help us to remember the order in which these three ratios go together with their respective sides. Well, to get the inverse ratios, we're just going to flip everything. That's all we have to do. Now, each trigonometry or trigonometric ratio has its own special inverse equivalent. So, sine has the inverse equivalent of cosecant of theta. And all we're doing is we're taking the sine ratio and we're flipping it. So we take the sine ratio and we flip it. So what we'll end up with is the hypotenuse over the opposite. That's all we've done. Likewise, for the cosine ratio, we have secant, and we take the cosine ratio and we invert it. So we take the adjacent and hypotenuse relationship and we invert it. And what we'll end up with is the hypotenuse over the adjacent. And likewise for the tangent ratio, we invert that. The inverse tangent ratio is cotangent, and we take the opposite over the adjacent side and we invert it. So we'll have the adjacent over the opposite. Now, just like with the trig ratios themselves, the original three trig ratios, we didn't want to write the whole word sine, and we didn't want to write the whole word cosine or tangent, so we abbreviated it. We do the same thing with these inverse ratios, and we abbreviate them so that the cosecant, we just write cosec. So cosec theta is equal to hypotenuse over the opposite. And the secant is just written as sec theta, which will be the hypotenuse over the adjacent. And cotangent is just written as cot theta. So we have the adjacent over the opposite. Now, the thing that I use to help me remember which of these is actually the right one to go with the sine, cosine or tangent ratios is if you look at the third letter of each of these words, the third letter matches up, if you think about it, with the ratio that it came from. So that's the little trick that I would use to help me remember which of the inverse ratios actually goes with which of the original trigonometric ratios. Okay, so we'll be using that also in terms of manipulating the ratios within the right angle triangles that we're dealing with in trigonometry.